Hi guys, and welcome to week 2 of Introduction to Mechanical and Automotive Engineering. I am your lecturer, Dr. Elizabeth Kiriakou, and last week we took a look at force systems and moments. We learned how to calculate the resultant force acting on a system. We took a distributed load and converted it into a concentrated force, and finally we looked at how to calculate a moment in a system. So this week we're going to expand on that knowledge and we're going to take a look at equilibrium. So what are our equations for equilibrium, how to draw our free body diagram, which is probably the most important thing you learn in engineering, and we'll take a look at reaction forces and how reaction forces actually keep a system in equilibrium, and finally we'll take a look at frictional forces. So what I've done is I've actually broken this up into a couple videos, so then we can just have some small sections of information at a time. So let's look at equilibrium of a rigid body. So what do we mean by the term equilibrium? So for a system to be in equilibrium, the sum of the forces must equal 0, and the sum of the moments acting at any point must also equal 0. So if we take a look at a truss, similar to what you'll be designing in your workshops this semester, we have external forces. So this is an external force here, this is another external force, and here we have another external force. Over here, so we'll just write that in. So that's called an external force. And then over here we have a reaction force and another reaction force. And these reaction forces are also external forces, and this is what keeps our system in equilibrium. So, what are our conditions for equilibrium? But before we look at that, let's just take a look at this word, rigid body. What do we mean by rigid body? So a rigid body is an idealization of a solid body, whereby we have no deformation occurring in the system. So later on in this semester, we will take a look at deformation in systems. So for our conditions for equilibrium, what do we have? So we can say that sum of the forces equals 0 and sum of the moments has to equal 0. So in this class we're going to look at only 2D systems. So in 2D we know that force is a vector and it has an x component and a y component. So we can assign a direction, and we always put an axis on our diagram. And we can say that sum of the forces in the x direction equals 0, sum of the forces in the y direction equals 0, and sum of the moments around any point is going to equal 0. If we were looking at these problems in 3D that you'll do next year in Mechanics 2, you'll actually have 6 equations. So you'll have sum of the forces in the x direction will be 0, sum of the forces in the y direction will be 0, and sum of the forces in the z direction will equal 0. And similarly, you'll have sum of the moments in the x equals 0, sum of the moments in the y equals 0, and sum of the moments in the z equals 0. So just remember, in this semester, we're only looking at 2D systems. So the next most important thing we need to learn about is how to draw a free body diagram. So let's just clean this up and take a look at free body diagrams. free body diagrams. Here we go. So what is a free body diagram? So a free body diagram is a graphical representation of our problem that is simplified so that we can actually solve it. So it's a graphical illustration. And this has got to be one of the most important things that you need to do before you solve any mechanics problem. So a free body diagram should include the following. We should have an axis, which we have here, and we can also define which way is positive for our moment. 2, we do a simplified drawing. 3, we include all forces acting on the system. 4, all moments acting on the system. And 5, we need to have all dimensions. So basically, a free body diagram should describe our problem without this question sitting up here. So, since we have this truss going on, let's draw a free body diagram of the truss. So here, we'll draw the frame. We have some external forces. So here we have 5 kilonewtons. Here we have 6 kilonewtons. Here we have 8 kilonewtons. And at point A and B, we have reaction forces. So here's a pin, and we have a roller. That's a roller. And that's a pin. In the next video, we will go into the types of reaction forces that we have. But in a pin, we will have a, this is A, so we'll have an A component and a Y. And in a roller system, we'll just have, this is B, have a BY. So the last thing left to do on our free body diagram is to actually put our dimensions on. So we have 2 meters, and 2 meters, and 2 meters. So the last thing we should do is always write out our equations for equilibrium. So sum of the forces in the x direction equals 0. Sum of the forces in the y direction equals 0. And sum of the moments around any point is going to equal 0. So now we should be able to solve and find the reaction forces in our free body diagram.